All right, so Sammy, if you end up watching this video, hope you don't have the coronavirus or anything like that. Actually, did you guys hear that they found a cure?
What?
Yeah, they found a cure. It is an HIV treatment. Don't quote me on this. You can go research it. But a team of doctors, and kind of like experimenting with what might work, what might not. They were isolating what was actually causing like the illness. Now, take this with a grain of salt because it's from my like Reddit world news feed. So like I haven't verified this, but it seems as if we're like working towards figuring out the cure, which of course we're always trying to with any new diseases. But yeah, as dramatically worried as people are / were, we will soon, hopefully, not need to be so worried because they will be able to tell us, hey, just give this to people. Dude, Reddit has a lot of good content. For all of the bad content on Reddit, there's also good content.
Okay.
So if you follow like our U.S. news or our world news or our like current events, or like there's some legitimate threads on there that aren't just people yelling insults. So 8.1, sorry, my dot camera's taking forever. 8.1 asks us to construct equilateral triangle ABC. How would we be able to construct? Well, what does equilateral mean?
All sides are equal.
All sides are equal. So we can make that happen using some of these tools that mathematicians have been using for a long time. Right now, when we talk about a straight edge, we're really normally talking about a ruler, but we call it a straight edge because in the beginning we didn't have like the actual tick marks on the ruler. But if we did, we'd see this is about 5.6 centimeters, right? Or if we didn't have a straight edge to work with, I had a compass sitting over here. Maybe one of you guys stole it. We could use compass, right? And a compass would lock in whatever distance we tell it to. So if you pick up your compass and look at it, I want you all to understand when you get annoyed at your compass, how to fix it. Liang, are you going OCD for a minute? Yeah. This screw, if you have your own compass, that being tight or loose is how you determine how rigid it holds this distance. You want to make sure that these are about the same length. So I would actually first loosen this, and you can hold it on your table. This is always what I do. I just do this, like to line these up at the same length down. Then I lock in my pencil. Now that's not like super critical unless you're working with smaller distances, but we can lock in our length just by spreading our compass to this distance. Now here's the really cool thing. If we just used a straight edge, right? Hey, eyes up on the screen for a second, because watch me fail. Oh, hey, here's the compass I had sitting over here. It wasn't you guys. I was just accusing you when I knew it wasn't you. So 5.6, right? Maybe 5.7. No, if I line this up, 5.6. So I could guess, right? Okay, 5.6. This might be, but would that be an equilateral triangle? No, because there's no way that this would be 5.6. So I could try another 5.6 and measure back to here. No, that doesn't work. I could try another 5.6, but this is really, really frustrating. That's why the straight edge is not the best tool, because we're looking for some point up here that will perfectly create our equilateral triangle. That's why we use the compass. Idea?
Well, so couldn't you just like use the Pythagorean theorem to like find the middle point and then like so you know like the hypotenuse and the bottom leg, and you can just find the other leg and go that far up and then down.
Wow, you want to do a lot of work, don't you? Are you just like, are you just dying for work to do?
Wait, find a midpoint.
Why would find a mid? So they do want a median of AM. So M, M is going to be over here. If it comes from A, M is going to be out here. Anybody have ideas? Aside from what Sophia said, because that seems complicated.
I have a different thing.
Okay.
So yeah, if you use the compass and then you put the sharp point in the middle and then you just bring the pencil out and around and make a semicircle.
Sharp point in the middle. Why would we put the sharp point in the middle?
And then so you could rotate the pencil.
Wait, how do I know this is the middle? Like the exact middle or like approximate middle?
Measure on the ruler.
Well, what if we didn't have a ruler? Because I already kept trying to measure and mark and measure and mark and measure and mark, and I got frustrated, so I threw the ruler away. So now I don't have the ruler.
Well, you have the, you can figure out like the radius, and wouldn't that just be the distance from
The
the
radius? Why do you keep talking about circles? Watch this. About to blow your mind. If I put my sharp point here and my pencil here, and I start to draw an arc, every single point on this arc is the same distance away from A, right? Because this is a locked distance, locked distance, locked distance, locked distance. If you feel like this won't stay tight, stick up a hand, I'll come around and tighten it for you. Because that screw is the way. So draw that arc. Put your sharp point on A, put your pencil on B, and arc it up, keeping this locked the whole time. If it's too loose, give me a hand, I'll come around and adjust it for you. If they're brand new, I probably need to tighten them.
Mine feels really tight.
That's actually pretty loose. Because when you go to press on it and try to draw arcs, it wants to spread out. Like it naturally just wants to spread out. The metal ones are better, but they don't really sell the metal ones anymore because you can stab people with them. Guys, I'm just honest with you. I hope at this point you realize, like, I'm just honest with you. So if you grab one of my metal compasses, the pointy end is really pointy.
We just go all the way around.
You don't have to go all the way around. Well, you're going to make your paper really crowded. So, if all of these points are equal distance from A, then any line I would draw connecting that would make me an isosceles triangle, right? Because then I could just connect down to B. If I do the same thing flipped, put your sharp point on B, put your pencil on A. Now here's an easy way to draw an arc. Hold your sharp point, rotate your paper, hold your sharp point where it is, and gently just turn your paper, actually. Everything on this arc is A distance away from B, which means this point is the top of our triangle. So now I can use my straight edge that I went and picked up from wherever I threw it and draw this line down and draw this line down. And label this C. Please leave these arcs. Do not erase them because that is how you can remember how in the world you were able to draw this. Arcs, not circles, but okay. I'll let you say circles if you really want. Now, a median. What is a median? Middle. But it says median AM. So M is going to be on what line? AB. Well, wait. Median AM.
Would it go like straight through the middle?
If we don't know what we're doing. What is a median of a triangle?
It's the middle. It's the middle.
Line segment that joins a vertex and a midpoint of an opposite side of a triangle. So if A is over here and we're trying to find M, M can't be on this side. M has to be on BC. Because we want a median that goes to a midpoint M over here. Now remember, this is an equilateral triangle. It's the same triangle this way as it is the other way. It's the same triangle this way as it is the other way. This triangle has no up and down, really. But now what we're looking for is a midpoint on this side. Now, again, if we say we don't have our straight edge, because I threw it out the window, and even if we had a straight edge, it's not a ruler. We assume it's a ruler because we live in the 21st century. Straight edges were not rulers back then. It was just a straight edge. How could we find the midpoint of BC? I want you guys to talk with each other for a second. I want you to get creative. No measurement.
Do another
Like
arc.
split the triangle in half a bunch of times. Just go from any point and straight down the middle. Yeah. Like C and then.
How do you know it's straight?
Straight edge.
One of these.
Threw it away.
Nope, you don't have a protractor. You don't have a ruler. You have a straight edge and a compass. I wish Sandy was here. She's missing a fun day. Today, constructions I think are pretty fun because it's like, how do we do this? And then once we do it, you're like, oh my gosh, it works so easy.
Continue making semicircles. Just go around.
No, just keep
I don't disagree with we should make some more arcs.
That's what I said. Oh, we make like circles around A and B and then C and then that'll do something.
Play with it for a minute. Take 3 minutes on your own to try whatever you think could accurately find a midpoint. I'll even offer up, if any of you accurately get to what I'm gonna show you, I'll give you a piece of candy because I don't think you're going to. It's weird. Like, I'm not saying I don't have confidence in you guys, just the jump of, oh yeah, that would work. Like, that's hard to get to.
So we're using the circle to do something.
Sorry, I have Dance Monkey stuck in my head. Something terrible. You know, Dance Monkey, Dance Monkey.
Oh.
Dance Monkey.
Alright, this is okay. So if you make a little like mini circle like from the same length, so it doesn't really matter what length, just make it the same length. I didn't change the length, I just did that and I just made circles. And then you have a middle. So make it like, it has to be like kinda long. Make it like 2 inches. And it's like, I did like that. I didn't change the length. I'm not using a specific length, I'm just gonna change it. And then I made a little thing in the middle. That's probably.
What do you mean there's a middle? I see a triangle in the middle of your triangle.
Well, yeah, if you went through that point and then that point and then that.
But we're trying to find the middle of this.
Well, those he marked on there as congruent markings. Those aren't marked by any other reason, are they? Am I missing a fact? You're halfway there.
Wait, but if you had a straight edge, you had both of those. Couldn't you just do whoop and line it up with both? You
So
said
you're using that point, but what else are you using?
that point.
Well, that's an interesting question. Would coming from this vertex through that intersection get you to the midpoint?
Yes. Yeah.
Let's test this somehow. Try it, then measure. Now, I will let you measure that, but I'm going to show you an easier way.
Okay, I don't know how we did that though. I just gotta. Okay, here. I just missed it. Okay. So I just.
Liang, you want me to help in it or jump in and formalize this?
No, can be.
And then you just like do the thing.
But he's only halfway there, so unless he gets the other half.
Oh, so you make baby turn.
You just like
Baby. You
like
go
really
from
big-
half.
No, you don't have to.
You do not need to do that.
You know what, Hudson? I want your fear of them.
Like the length doesn't really matter. Just, yeah. Just like make them look triangle. Start changing.
You guys want to see the easy way?
Yes.
Wait, yes.
If it means no candy in it.
Yes.
You know that I'll always give you guys candy pretty much. Now, if I give you guys candy, I will have to give Sammy candy on a day that she's back here.
Well, that's fine.
Because otherwise it's not fair.
Well,
Check it. Check it. Like, check this out. BC, I want an M somewhere in the middle of that. I could guess. Maybe the middle. But what I could say definitively is that's not the middle. That's further than the middle. Right? So if I do what Liang did and pick a point that I know is further than the middle. Further. Watch. Don't do. Watch. And arc. No. And then keep this locked at the distance we just had. Okay? Flip it. Keeping it locked. And we arc. Like Liang did, but what you didn't have, Liang, are the outside of the triangle parts of the arc. You had all the insides of the triangles. I'm done. Because now I don't need A. This point and this point, when connected, create not only the midpoint of the triangle, or sorry, of that edge, it's actually perpendicular as well. And if we check what Liang had said about coming from the A through that point, it should just about work. Now, I do not guarantee that it always works, but if we were testing did Liang's hypothesis work, probably. But the real way that we find a midpoint, and you might want to write this down on your paper because none of you knew it before this lesson, was use your compass, go more than halfway. Arc it from point 1, right? If you're working with 2 points, you have like point 1 and point 2. Do the same thing from point 2. Connect those arcs, like kind of like the eye that you've made now. And that will then mean this length and this length are equal to each other. Then that actually means that this angle is congruent to this angle. Because if this is the midpoint, hinge theorem would tell us this is congruent to that. Because we've essentially created 2 congruent triangles, right? If this was equilateral, then this angle was equal to this angle. And by side angle side, we've created equilateral triangles. Or actually, side angle side could have used that this is perpendicular. We could have used that. You ready for another challenge? Okay, well, it's for candy. What's an altitude? Yeah. The height when
So it's going up? When it's going forward.
When it's going down.
It's like the slope. Like the height increase when it's going forward.
I think
altitude is height when measuring perpendicular to the ground, right? So this, look, it matters. This would not be an altitude. Even if I like literally have something that is leaning like this and I measure a thing like, that's not an altitude. If I stand it straight up, now it's an altitude. So MJR could have 3 different altitudes depending on which side we treat as the base. The biggest thing that matters is that we pick a base and make an altitude off of that. So if you're going to use RJ as your base, we need to be perpendicular to RJ. If we use MR as our base, we need to be perpendicular to MR. If we use MJ as our base, we need to be perpendicular to MJ. Based off what I see and the angles that I can approximate, the easiest base for us to use would be RJ. So let's assume this is our base, so our altitude will come straight up to M. Crap. So we need it to come from M, drop straight down, and be perpendicular. And all we have is a compass and a protractor. How can we make that happen? I'm going to leave this in your court for a minute. How can we do this? Remember, your straight edge is just a straight edge. We can't use it to make perpendicular.
We use this. And we're trying to find the midpoint of RJ.
No, you're trying to find an altitude from M down to RJ.
Okay. Just use a ruler. Oh, if we find a midpoint of this, line. We look at what we did over here. So what's these triangles?
It's not equilateral, so you can kind of use that.
It's not equilateral.
Make another line, and now it's equilateral.
Oh, maybe you put your sharp end at in the point where it touches the RJ.
Wait, I don't get it. Couldn't we just make a random line? Is that, oh, look at that. Oh, okay, it's still the same. No, okay.
Could we?
I didn't even listen to the question he asked. I was in my head thinking about what I could ask you. Athena, you're quiet over there. What are you thinking? Nothing at all. Blank brain.
No, but I'm serious though. We can't do it because it's not an equilateral triangle. So what if we make it?
What a quitter.
What?
You. Yeah. You said we can't do it. What a quitter.
No, I was proposing a solution, and you cut me off. What an interrupter.
No, you said we can't do it. There's no interrupting after you say can't. You know that poster that's over by the 8th grade classrooms that says those who say it can't be done should get out of the way of those doing it?
But I was proposing a solution.
With only a straight edge and a compass?
Sure. You just...
Because you're trying to force an equilateral triangle and...
Pretend you have an equilateral.
Why don't you just do the same thing that you... Oh, wait.
What do you mean the same thing?
Wait, never mind. I realized that what I was saying, I don't think would work. Because I was gonna ask if we could just do the same thing, but you kind of have two angles already set up.
What did you do? Yeah, those who say can't should get out of the way.
You just said it, so goodbye.
Oh no, I need to get out. Bye. Good day. Who made that poster? Those who say can't should get out. What happened to you? I mean, but technically.
So wait. David, you said draw a line to make it an equilateral. Where were you talking about drawing the line?
From M to a point
down here?
Line RJ, yeah, to make the triangle equilateral.
How?
With a straight edge.
But how do we know it's equilateral?
Because we're imagining.
How can we know it's equilateral?
We use this, and then we make a circle with something, go, and then well, look at that.
I found something. I don't know if it's helpful.
Then do it, Liam.
So hold on. If I try to do what you just said, David, this length MR, right? So this, if I do that, that's the length of MR, right? Because I locked that length.
Yes.
So this hypothetical side that we don't have creates a quote-unquote equilateral.
Oh my gosh, holy jaboli, whoa.
You don't need
No,
to check. No, you don't.
know if it's equilateral or not.
No, you do.
Well, it's at least isosceles.
Yeah.
Okay. So Sophia caught me on the fact that it's not equilateral, it's isosceles.
We have a protractor. We can find the
We
length.
don't have a protractor, they're not invented yet.
Wait, but this is 2020.
No, it's
No,
not.
but then we can use
What
this
year
thing
is
for-
it? Archimedes.
If you don't, if you keep the distance locked, you can see if it's equilateral. Like,
Did we time travel back to the time of like what? What time?
So wait, if this is true, and we got that by essentially doing this, we have an isosceles. So then you're saying do the same thing we did? Like the whole over a half and make the arc? That thing?
we don't have any lengths.
David, you with me? Because what I hear is you smacking your ruler.
Okay, I'm gonna assume our students to do this one because he's doing it.
I'm following what David said, but he said it, but then I don't know how good of a job he's doing.
And wow, look at that. You have a middle thing and another middle thing. That. Okay, so let's see. That. Okay.
So that,
Yeah, sure. We're trying to find the altitude.
you're not wrong, but what you did was unnecessary.
Wait, so that was what you said.
Wow.
Okay, I'm so-
I mean, close enough. Right?
Do we need 2 points on this eyeball thingy like we did up here?
Probably not.
Not really, because we know we're using M, right? So we really just need a point out here to line up M with, or a point in here to line up M with. We didn't need to create an equilateral triangle, or an isosceles triangle.
I feel so.
Although, what we did need to do was create some kind of arc with equal lengths.
Dang, look at that.
Can I, well, sure, you can ask, but I gotta remember to connect what I'm trying to connect right here.
Alright, so maybe if you put the sharp thing in the where the right angles are, like
But we don't know that's a right angle.
like
I can't make that a point until I've made it a point. You know what I mean? I can't put my point
call
there.
it A, call it
It doesn't exist.
A.
Before we create it, it doesn't exist. No, I will not call it A because it doesn't exist.
Alright, then do M.
Can I pull together the shortcut to what David did? All you need to do, now what David did wasn't wrong, but all you need to do was lock your compass into a distance. It doesn't really matter what distance. If it's bigger than here, you need to extend this side. So any of these, with our straight edge, let me just throw some things real fast. I can extend this, right? I should have given you a straight edge that was not a ruler, but I could extend that out real easy. All you have to do is pick a distance. Let's say I went bigger. Arc it. Meh. Use the 2 points. Notice I'm doing it differently than what we did with David. Use the 2 points that cross that base. Pick some distance. Doesn't really matter, but it needs to be more than where you think it is. Right? So where I think it is right there. So you could go real big if you want. Watch this, actually. I'm going to make this fun. Check out what happens here. My arc goes way up here, but that's okay. Because then when I go from this point, sorry, I'm waiting for it to zoom. That point is equidistant from that point because I made them from M. Right? When I do that, my intersection point is actually way out there. But look at what happens if I line this up. It lines up to that point outside the triangle. So that point through this point M, when I connect this point of my arcs through this point, it creates my altitude. So this process again, we start at the point we're using, and you could write this down like out here if you want. We start at that point. We arc to intersect the base. The only thing we care about is that we intersect the base. Then, from those intersection points, we arc more than where we think it is. So it could be close, like we did right here. Could be far away, like we did out here. Then, connect. That's how you find an altitude. Now here's the issue. If we go try to do that from J or R, when we think about coming straight down to this base, this might be 90 degrees right there. And if I connect from J into here, it looks like it's less than 90. See like where my cursor is, where it's kind of meeting right? I know it's shiny, so it's kind of hard to see. But that looks to be like not, like that's obtuse / acute. I don't know that I can draw an altitude from here, or it might end up outside the triangle. That happens. Altitudes sometimes end up outside the triangles. So if you worked from J or worked from R trying to drop an altitude, your altitude may not end up inside the triangle, right? Because that's definitely not 90, not 90, not 90, not 90. I think I have to push past here to get to a 90-degree point. Does making the altitude make sense now? So it won't really make sense if you try it on your own. Move on to part C. We want to try to construct an angle bisector of P. So we talked in A about something that results as an angle bisector. I want to give you the remaining 3-ish minutes that we have to try this. Tomorrow we will be starting your mastery, and I will not be here. So I will be on, an instructional round with Mr. Beck and Miss Lemire. Mrs. Lemire and Mr. Beck and myself are going to go observe other schools tomorrow to try to beg, borrow, and steal some awesome things to bring to Phoenix. You can be upset because it won't benefit you because we probably won't implement it till next year, but I won't be here tomorrow. Because of that, you'll be starting your mastery. I heard the guest teacher is Mr. Duke, just like it was yesterday, but you guys didn't have him because I was here. If I say Sam Elliott, do you know who I'm talking about? The guy with the white hair that is like if somebody is portraying an old man in a movie, like they normally cast Sam Elliott because he seems like an old wise, like somebody that would give you advice or something, right? He's all white haired, mustache, this guy sounds like Sam Elliott. So if you don't know who that is, tomorrow you might be like, oh, here, I'll show you.
Stop it, Leanne. What are you doing? Leanne.
This guy.
No, I don't.
Yeah, you've probably seen him in TV shows and stuff
Never
before.
seen him.
He was on one of the new Doritos commercials too.
Really?
Yeah.
Bro, acting wise on a Doritos commercial. Very not.
It's a funny commercial.
What were they trying to do? Like,
Here, watch. Actually, I should probably stop my recording.